So now we're going to concentrate on how you can solve inequalities graphically. So for example, notice you're given no equations, you're just given a graph of a line and a parabola. And we want to know where is y1 greater than y2. So y1 is labeled as the parabola, y2 is the line. So what I like to do is I like to highlight one of them. So I'm going to go ahead and just highlight y sub 1. So just like we did with when we were trying to solve algebraically, you want to identify the critical numbers. The critical numbers are coming from where these two particular graphs are intersecting. So in this particular case, the graphs are intersecting at the x values of -2 and +2. So if you think about what we just drew our number line, there's my critical numbers, -2 and 2. Again, I want to know where y1 is greater than y2, not where they're equal. So again, I'm not going to be including -2 and 2 on the solution set. Now remember, we are comparing the y values. Where are the y values of my parabola greater than the y values of the line? So that means where is the parabola above the line? So right here and right here, notice that's where my graph of my parabola is above the line. So what that tells me is that the solution to this particular inequality is going to be where the values are less than -2 and greater than -2, as I've shown in the green. So in interval notation, this will be -infinity to -2, and then 2 to infinity. If you look at number 10, you have where is y1 less than or equal to y2. So I'm going to go ahead and just highlight y1. Identify your critical numbers. That's where the two graphs are intersecting. So my critical numbers are going to be at -5 and 4. Again, I want to know whether less than or equal to. So this is where the two graphs' y values are equal, at -5 and 4. So I am going to include those values in my solution set. So I want to know where is the line, y1 is the line, y values less than the parabola. So if you notice right here, between your critical numbers, that's where the line is below the parabola. This is where every point on here has a y value less than the parabola. So your solution set's going to be bracket -5 to 4. Here's a different kind of graph. We want to know where is y2 less than y1. So y2 is my line, so I'm going to go ahead and just highlight y2. I still need to identify the critical numbers. In this case, I have 3 of them. So my critical numbers are at -1, 1, and 3. I'm not including them because it's just where it's less than, not where they're equal. So now where is my line less than the cubic function? So notice right here, you can see that the line is below y1. Right here is where the line is below the cubic function. So again, my solution set's going to have to be between -1 and 1, and then 3 to infinity. So then in interval notation, my solution will be -1 to 1 and 3 to infinity. So we'll be comparing the y values. Where are the y values less than that of y1? If you look at the last one, number 12, where is y sub 1 greater than or equal to 0? Remember, 0 is just simply your x-axis. So again, your critical numbers in this particular case is going to be where your graph is crossing the x-axis. Crossing the x-axis at -4, -2, and +1. I want to know where it's greater than or equal to 0, so again, I am going to include the critical numbers in my solution set. So where is the graph of the parabola above 0? Right here, and right here. So as you can see, that's where your graph of your cubic function is above 0, where it's above the x-axis. So I know it's going to be between -4 and -2, and then 1 to infinity.